Hello students, we're going to solve in this example number 1, as shown in your course notes. Specifically, the situation is this. You are told that on February 29, 2013, the stream concentration of E. coli in the Ottawa River is 0.01 micrograms per liter. You're then informed that as a result of heavy precipitation and the specific situation with the City of Ottawa with having combined sewers, a fair bit of raw sewage is then thrown into the Ottawa River. Specifically, the concentration of the waste is 30 micrograms per liter. You're then informed that the flow of the stream, that is of the Ottawa River, is 1.95 megaliters per second, and that the flow of this waste being put into the Ottawa River, untreated, is 0.005 megaliters per second. You're then asked, by using the formula at your disposal, what the diluted concentration is after this waste has had a chance to mix into the Ottawa River within the mixing zone. Specifically, what the diluted concentration is, and you have this formula at your disposal. As a review, this formula describes this. The diluted concentration is equal to the ratio of the product of the concentration and the flow for both the stream and the waste, the sum of these two products, divided by the sum of the flows. Let's get to it. First, I want to remind you of these subscripts. You see these subscripts S and W? They refer respectively to stream and waste, so the concentration and the flow of the stream. D stands for diluted. Let's solve this. I'm first going to look at all the values that I've been given, and I can see that each one of these actually corresponds to each one of these quantities. So I can actually proceed to use this formula to compute the diluted concentration. Voila. So all I did is I took each one of these quantities which I was given, put them into the formula. This is what I get. Next step is I'll start calculating. I'm going to do it a little slower than perhaps what you're used to, just with the intention of covering all steps. The beauty of having this on video is that you can fast forward, rewind, pause, replay if there's something you're unsure of. Additionally too, you can also, if you choose to, send me an email to this email address. Okay, so the diluted concentration is equal to the product of these two quantities So take a moment to note up here, if I'm multiplying the numbers, that means I'm also multiplying the units. That's why I've written out the units as follows. Voila. Do you see what's about to happen to the units here? That's right. Megaliters per second cancels out with megaliters per second, and all you'll be left with is micrograms or milligrams per liter, which, as it turns out, is the unit for the concentration. So the diluted concentration of this waste that's been dumped into the Ottawa River is actually 0.087 micrograms per liter after it's had a chance to mix within the mixing zone. How does this compare to the original concentration in the Ottawa River? Well, it's almost 9 times larger. Okay, so heavy precipitation and the dumping of untreated raw sewage into the Ottawa River can have some fairly serious effects. Another question is, how close are these numbers to reality? They are fairly close. They're quite representative. Okay, we're not done yet. The final step would be providing a concluding statement. That is, expressing explicitly what your final answer is. Therefore, the diluted concentration is equal to 0.087 Therefore, the diluted concentration is equal to 0.087 micrograms per liter.